Hey there, builders and makers. Let's talk about CNC machining. This technology is amazing. We can create incredibly precise parts from digital designs, but even the most advanced CNC machine is only as good as the instructions it receives. That's where clear, accurate technical drawings come in. They are the language we use to communicate our design intent to the machinists who bring our ideas to life. Think of it like this: you wouldn't build a house without a detailed blueprint, right? The same goes for CNC machining. A clear drawing is the blueprint for your part. It tells the machinist everything they need to know to make your vision a reality. A well-crafted drawing ensures everyone is on the same page, from the engineer to the machinist. This shared understanding is crucial for preventing errors, reducing waste, and ultimately, saving you time and money. Imagine this: you've designed an awesome new product. You've spent hours, days, maybe even weeks perfecting it in your CAD software. You send the drawings off to the machine shop, excited to see your creation come to life. But when the parts arrive, they're not right. Something is off. Maybe a hole is in the wrong place, a dimension is incorrect, or the finish is rough. Now you're facing costly rework, production delays, and a whole lot of frustration. This scenario is all too common, and it often boils down to unclear drawings. A seemingly small error or omission in a drawing can have major consequences in the machine shop. A missing dimension, a misplaced symbol, or an ambiguous note can lead to misinterpretations, wrong cuts, and ultimately scrapped parts. Clear communication is key. That's why mastering the art of creating clear and accurate technical drawings is essential for anyone involved in CNC machining. It's about more than just lines on paper. It's about ensuring your designs are manufactured exactly as you envision them. Every great building needs a solid foundation, and the same goes for technical drawings. The title block is the foundation of your drawing, providing essential information about the part and the drawing itself. Think of it as the ID card for your part. A well-organized title block should include part name. This one is pretty self-explanatory. Drawing number. This unique identifier helps you keep track of different versions of your drawing. Revision number. As you make changes to your design, the revision number helps you track the latest version. Material. Let the machinist know what they'll be working with: aluminum, steel, plastic, etc. Units. Specify whether you're using inches or millimeters to avoid any confusion. Scale. If your drawing isn't drawn to actual size, the scale tells the machinist how to interpret the dimensions. Surface finish. More on this later, but this specifies how smooth or textured the part's surfaces should be. A clear and complete title block ensures everyone is working from the same information and helps prevent costly mistakes down the line. So, take the time to fill it out accurately and thoroughly. The heart of your drawing lies in the depiction of the part's geometry, its shape, size, and features. This is where your design truly comes to life on paper. Clarity is paramount here. Here are some tips for clear geometric representation. Orthographic views. Use standard orthographic projections, front, top, side, to show the part from different angles. Think of it like taking pictures of your part from different sides. No clutter. Keep your views clean and uncluttered. Avoid unnecessary lines or details that could cause confusion. Proper line weights. Use different line weights to distinguish between visible edges, hidden edges, and center lines. This helps the machinist understand the part's 3D form. Remember, the goal is to create a drawing that is easy to understand and interpret. Avoid any artistic flourishes or stylistic choices that could obscure the part's geometry. Think of it as technical communication, not fine art. Section 5. Tolerances and fits precision communication. In the world of machining, precision is key, but we don't live in a perfect world, and manufacturing processes have inherent variations. That's where tolerances come in. Tolerances tell the machinist how much variation is acceptable for a given dimension. Critical dimensions. Identify the most critical dimensions that directly impact the part's function. These dimensions need the tightest tolerances. Limit dimensions. Clearly indicate the upper and lower limits for each dimension. This gives the machinist a clear range to work within. Hole fits. Specify the type of fit required for holes and shafts, for example, clearance, location, or press. This ensures proper assembly and functionality. Clearly communicating tolerances ensures that your parts will fit together as intended and function properly. Remember, precision is in the details. Section 6. Surface finish. The feel of quality. The surface finish of a part can be just as important as its dimensions. It affects the part's aesthetics, how it interacts with other parts, and even its durability. Use raw or roughness average values to specify the desired surface roughness. Lower raw values indicate smoother surfaces. Familiarize yourself with standard surface finish symbols and use them consistently on your drawings. Whether you need a mirror smooth finish or a more textured surface, clearly communicating your surface finish requirements ensures the final part meets your expectations. Section 7. Datum references, the anchor of accuracy. Datum references are like anchors for your dimensions and tolerances. They establish fixed points of reference on the part, ensuring that all measurements are taken from the same starting point. Geometric dimensioning and tolerancing, or GD&T, is a powerful system for defining and communicating datum references and geometric relationships. Use GD&T symbols to control the location, orientation, and form of features relative to the established datums. By clearly defining datum references, you ensure that all features are manufactured in the correct relationship to each other, resulting in a part that assembles and functions as intended. Section 8. Avoiding ambiguities, double-checking for clarity. Before you send your drawings off to the machine shop, take the time to double-check for any potential ambiguities or inconsistencies. A few minutes of careful review can save you hours of headaches later on. Avoid redundant dimensions that could lead to conflicting information. Ensure that all dimensions and tolerances are consistent across different views. Carefully compare different views of your part to make sure they all agree. Remember, the devil is in the details. A thorough review process helps catch errors early on, ensuring that your drawings are clear, accurate, and ready for manufacturing. Section 9. Checklist for success. Your blueprint for flawless CNC machining. Congratulations! You're well on your way to creating crystal clear technical drawings that will make your machinist happy and your parts come out perfectly. Here's a handy checklist to use as a final review before you hit send on those drawings. Part name, drawing number, and revision number are clear and accurate. Material, unit, scale, and surface finish are specified. Orthographic views are used to show all sides of the part. Views are clean, uncluttered, and easy to understand. Proper line weights are used to distinguish between different types of lines. Critical dimensions have appropriate tolerances. Limit dimensions are clearly indicated for all features. Hole and shaft fits are specified for proper assembly. Raw values or surface finish symbols are used to specify surface roughness. Datum references are clearly defined using GD&T. Geometric tolerances are used to control the location, orientation, and form of features. Drawings are free of ambiguities and inconsistencies. Dimensions and tolerances are consistent across all views. All views have been cross-checked for accuracy. By following these guidelines and using this checklist, you can ensure that your technical drawings are clear, concise, and error-free. And that, my friends, is the key to unlocking the full potential of CNC machining and bringing your designs to life with precision and accuracy.